In this question from the chapter relation, the question says that show that the relation S in the set A and the set A is defined as X is greater than equal to 0 and less than equal to 12, where all X is an integer here, given by the definition, which is the definition of this relation S indicated by S, AB, such that A minus B is divisible by 4. We need to show that this relation is equivalence. Further, we need to also figure out all the set of elements which is related to 1. As you must be knowing that in order to prove this relation, an equivalence relation, we need to prove that this is reflexive, symmetric, as well as transitive. Now, starting with reflexibility, you know that in order to prove this function to be reflexive, we need to prove that A belongs to R, not R. This is S. This time the definition here is of the relation is S. For every A that belongs to this set A. Now, what we should do here is, let's take any integer that is between 0 and 1, including 0 and 1, we'll find that A minus A whole modulus is equal to 0. And then you should say that 0 is divisible by 4. 0 is divisible by 4. So we'll say that it is reflexive. This is reflexive. Now, in order to show that it is symmetrical, what we need to do is that if AB belongs to S, then BA also should belongs to S, then it becomes transitive. So what we can do, we can take AB such that let AB is taken, AB belongs to S, implies that A minus B whole modulus is divisible by 4. So let's say I took as 4m, right? Therefore, B minus A, right? B minus A, flipping the order, will again be 4m. As you know that A minus B whole modulus is equal to B minus A whole modulus. This implies that BA belongs to S. So therefore, it is symmetric. This function, this relation is symmetric as well. Now, for the final part, whether it's a transitive or not, what we are going to do is in order to prove it transitive, AB as well as BC, right? AB and BC should belongs to S. And then we have to also show that AC, if it belongs to S, then we say that it is transitive. Now, for that, what I'm going to take is, let's say, first I'll take, we can take that A minus B is divisible by 4. So I'll take this as 4m. And B minus C is also divisible by 4. So let's say it's 4n. Now, if A minus B is divisible by 4m, what does it mean? That it will be A minus B without modulus will also be divisible by 4. And similarly, B minus C without the modulus would also be divisible, right? It's a divisible whether it's a negative or positive. So if I mark this as equation 2, or in case if I add these two equations, if I add these two, this B and minus B get cancelled. So we turn up getting A minus C is 4 times m plus n. So if A minus C is divisible by 4, it implies A minus C, it will be divisible by 4 m plus n. So this indicates that AC also belongs to R. Sorry, it's not R, it is S here. Belongs to S. So we'll say hence it is transitive. Now we have to find out all the elements which are related to S, right? Related to 1, not S. This is all these elements. From the above, what we can say that the relation S is reflexive, symmetric, and transitive. And all those elements which is related to 1, what does it mean to say? It means to say that, let's say, if I erase this part and I'll do it here. So I have to fix 1 as, say, at A, I fixed 1 here. I fixed 1. 1 minus what should give you divisible by 4 such that it should be from 0 to 1. Clearly 1 minus 1 is divisible by 4, right? That's for 0 only. 1 minus 1 is divisible by 4. Let me show it properly. But I mean to say that here 1 minus the modulus, right? This is modulus 1 minus 1 is divisible by 4. And then 1 minus what? 1 minus 5 is a divisible by 4. That is 4 times m, 4 times n. And 1 minus what? I can take 1 minus 9, which is 8. That is also divisible by 4. And yeah, that's all. We cannot take a number further more than 12. So therefore, what do we find? That all those elements which is related with 1, I can see that the numbers which are related to 1 is 1 itself. Let me show you. Yeah, these are the elements, right? You can see that 1, 5, and 9 are related to 1 here. So we'll say that we have to find the set of all elements. So since it is a set, I should write 1, 5, 9 are the elements which are related to 1. That's the answer for the next part.